Military vehicles do not run by electricity like a golf cart, but they do require electricity to start and run many of the components such as radios, lights, gauges, and starters. Anyone who wants to keep these vehicles running needs to know about automotive electricity. Everyone is familiar with the uses of electricity, but not everyone understands what electricity is. Everything you see is made up of matter. An atom is the smallest piece of matter that still has the characteristics of an element. There are 102 known usable elements in the universe. An atom has a nucleus consisting of protons and neutrons. Protons have a positive charge. Neutrons occupy space with no charge. A number of negatively charged electrons are positioned around the nucleus like planets around the sun. The orbits of these electrons are contained in one or more shells around the nucleus. In some materials, the electron in the outermost shell may be pushed from its orbit of the atom. This movement of electrons creates the force we know as electricity. Some materials allow the electrons to move between atoms freely. We call these conductors. Others resist the movement of electrons. We call these insulators. One of the better conductors is copper. The only things better are precious metals like silver or gold. So we use copper wire to make pathways for electricity to follow. To make sure that the electricity continues to follow the wire, we wrap it with insulating material like rubber or plastic. There are some materials that are neither good conductors nor good insulators. These are called resistors. These can be made to do useful work in everything from electric heaters to solid-state electronic devices. We can attach a conductor to a place where there are free electrons, such as the positive terminal of a battery, and the other end to a place that attracts free electrons, such as the battery's negative terminal. Since like-charged particles repel each other and are attracted to unlike charges, the positive electrons will flow along the conductor to the negative pole. This is called a circuit. By breaking the circuit, we stop the flow of electrons. When electricity flows through a wire, it creates a small magnetic field around it. If we wrap the wire around a suitable core, such as soft iron, we concentrate the magnetic force. We know the magnetism is caused by the electricity because when we stop the flow of electricity, the magnetism goes away. Here we have the basics of any electrical circuit. A source of power, whose negative and positive poles are connected by a conductor that also contains one or more control mechanisms, and one or more devices that do useful work. All electrical systems are built up from these elements. There are several ways to create electricity. For example, certain chemical reactions produce electricity. This has been put to use in dry or wet batteries. Just as moving electricity through a wire can create a magnetic field, moving a wire through a magnetic field can create electricity. This is how generators work. Some generators produce alternating current, or AC, that changes direction as the conductor passes first through positive magnetic fields, then negative magnetic fields. Others produce direct current, or DC, that always flows in the same direction. Military vehicles use both AC and DC current. They use a rectifier to change AC current into DC current for most vehicle applications. The AC power is used in electronic control circuits. A rectifier uses diodes that only allow current to pass in one direction. There are other ways of generating electricity: by friction, by light, or by heat, but these are not used in vehicles. There are three ways to arrange an electrical circuit. One way is to place everything on the circuit in series. That means that the electricity has to pass through each element in one direction, resulting in a little less for the next element. This is called voltage drop. If the circuit is broken at any point, the flow of electricity stops. Switches are always wired in series with the elements they control. Another way of arranging a circuit is in parallel. Each element of the circuit gets its electricity independently of the other elements. Loss of one element does not affect any of the others. It is also possible to combine both series and parallel elements within the same circuit. Motor vehicles have two sources of power, one or more alternators and one or more batteries. The alternator is turned by the engine and does not produce any electricity until the engine is running and power is applied to it to create a magnetic field. The battery is used to operate some electrical equipment when the engine is off, but it is mainly used to start the engine. There are many devices on a vehicle that are run by electricity, so there are a lot of wires and connections. Ending the wires with connectors or terminals allows you to connect and disconnect the wires easily for installation and maintenance. See the technical manual for the kinds of connectors used on any particular vehicle. Since the body and frame of a vehicle are made of a conductive material, steel, they are used for one side of all the circuits. This means you only need half as much wire. By convention, the negative side of the circuit is connected to the body or frame. This is referred to as negative ground. A simple example of an automotive circuit is the headlight. When the switch is turned on, electricity flows from the negative battery terminal through the ground to the headlamps, then to the positive battery terminal, making a complete circuit. The headlights take a lot of current, more than you want to have at the light switch. To deal with this, you can use a relay. You can operate the headlight switch with an electromagnet. This allows you to control a lot of current with a much smaller amount. This arrangement is called a relay. When the headlights are turned on by pulling the switch, electricity flows from the negative battery terminal through the switches to the relay, where it activates the electromagnet and closes the relay. This completes the circuit and the lights come on. When you turn off the headlights, the circuit is opened and the current stops flowing through the electromagnet in the relay. The electromagnet collapses and a spring pulls the relay switch open again and the lights go off. The starting circuit is similar to the one we have just seen. A starter requires a great deal of current, so two relays are used in this circuit as well. Power from the battery first passes through the ignition switch. Many vehicles also include a protective control box that is activated by some aspect of the engine to prevent the starter from engaging when the engine is already running. Then the power goes to the starter switch. There is another safety switch that stops the power unless the transmission is in neutral. Finally, it goes to the starter relay, activating the starter solenoid. The solenoid works like the relay we just saw. It activates a mechanical arm that engages the starter to the engine, and it closes a switch between the battery and the starter motor. This sends power directly from the battery to the starter motor. Output from an alternator varies with the strength of the magnetic field. A device called a voltage regulator makes the appropriate adjustments to the strength of the magnetic field to provide a stable output. Starting an engine draws a great deal of current from the battery. One of the first things the alternator must do is replenish the battery so that it is ready the next time the engine needs to be started. Everything else on the vehicle will also draw from the alternator and needs to be attached to its positive terminal in some way. Some vehicles provide a bus bar for this purpose. There are many different circuits on a modern motor vehicle. It would be difficult to trace most of these by hand. That is why each vehicle has a wiring diagram that shows every circuit. This is still complicated, but it allows you to trace each circuit, starting from the source of the power. You should learn to read the diagram. It will save you a lot of trouble in the future. Vehicle electrical systems can be complicated, but they need not be mysterious. By consulting your technical manuals and the proper wiring diagrams, you should be able to solve any problem. Without them, you are just lost in the woods.